Okay, so determining the end behavior here is actually what we'll be doing, okay? Now, if you don't know what end behavior is, you can actually look back at my previous videos and you will be able to see what the end behavior is, okay? Well, let's start off with a graph here. Let's go ahead and get a graph. Get a graph going here. And let's get some function on here and we'll determine the end behavior of it. Say it goes here, comes down, hits that axis, dips down a little bit, goes back up, dips down, and then goes again, extends. Now, this is not the best graph of this here function, but it will work for what we're looking to do, okay? For what we're looking to determine. Because like I said, we don't care about this craziness in between here. We only care about its end behaviors right now, okay? So what would the end behavior of this function be? Let's say describe the end behavior. Well, what happens as x approaches negative infinity? Well, as x approaches negative infinity, p of x is approaching what? Well, where's x approaching negative infinity at? X is approaching negative infinity over here. Okay, x is approaching negative infinity over here. This is where x, let's say, and this is x where it approaches negative infinity, and it's over on this side here. But what does p of x do? What does p of x do at that point? Well, p of x is approaching negative infinity as well, okay? Because we see this graph here is going down as it gets further to negative infinity. So we'll say, as my x gets further to negative infinity, my p is starting to go down, p of x is starting to go down to negative infinity, okay? Now, what happens as x approaches? What happens as x approaches positive infinity? What happens to this graph? Does it approach negative infinity? Does p of x approach negative infinity, or does it approach positive infinity? What does it approach? Well, where does p of x approach positive infinity? Here, p of x will approach positive infinity here on this side. Well, if we're over here, what is this function? As we get, you got to think of it like this. As we get closer and closer to positive infinity, what happens to this graph? Well, we're here, and the graph goes down, but then it goes back up, then it goes down. Now, as we're moving further away from zero. So we're getting closer to positive infinity because we're moving further away from it in the positive direction. So we're going in the positive direction with respect to as of x. So this function is starting to go up. As we get over here to this, let's say this value here would be, let's say this will be 8. Okay, well, not to get it confused with infinity, let's say it'll be 10. Okay, so as we get closer to 10, what starts to happen? This graph starts to go up. It starts to increase because, well, look what happened. When we're right here, let's say this point here, let's say this point will be 2. And when we're at 2, let's say we're at 2, let's say this will be 3 here. We're at 3, and then this graph goes to 2. Okay, well, look what happens here. We're at 10, this graph is going to go up to what? Let's say that's going up to 7. So as my x goes into a positive direction, my p of x will also go into a positive direction, okay? Now, let's look at another example. This is the end behavior of this here polynomial function. Let me rewrite that. Oops. But yes, this is the end behavior of this here polynomial function. Let's do another example. Let's say here that I'm actually given this. I'm given p of x is equal to a minus 4x cubed minus 3x squared plus 5x plus 6. And it tells me identify the leading coefficient, degree, and end behavior, okay? Well, if you know from our previous videos, we know that the degree is the highest exponent, okay, in the monomials. So we're looking and we see the highest exponent is 3, so that means my degree, okay? This means my degree is actually 3. And let me write that here. My degree is equal to 3. And what else do we know that's obvious? Well, we know my leading coefficient We know my leading coefficient is equal to what? A -4. Okay, a -4. Now, you may say, well, how in the world do I get this? We've never talked about graphing polynomial functions just based on the equation. We never talked about that. All we talked about is this degree and this leading coefficient. So how do I get it? Get the end behavior. Well, if you remember from our previous videos where we actually talked about end behavior and understanding what happens to this end behavior, how this end behavior changes based on the leading coefficient in its degree. Well, this degree is an odd degree, okay? And this leading coefficient is less than 0. So the end behavior for any polynomial function with an odd degree and coefficient less than 0 is going to be this. As x approaches -infinity, p of x will approach positive infinity. And then as x approaches positive infinity, p of x approaches -infinity. Now, in order for you really to understand this, you have to go back to my other videos and watch it. But this would be the end behavior of any polynomial function that have these given requirements. Now, I'm told this by basically my leading coefficient and my degree. Now, all this extra stuff back here will determine how my graph reacts in the middle, okay? Because right now, all I care about is how my graph will act on its end behavior. So let's go ahead and graph that end behavior. See how that end behavior will look. Well, as x approaches -infinity, so we're over here. P of x will approach positive infinity, so we're looking like that. Now, as x approaches positive infinity, p of x approaches -infinity. So we're looking like this here. So we're going in this direction here. And if you remember from my video before, this looks exactly like the cubic function that we graphed before, this end behavior. Now, since this is not a since this is not the parent function of a cubic, it may have a little craziness going on to its graph. This graph may look a lot different, but of course it still has the same end behavior. Okay, it has the same end behavior. All right, let's do one more example here before we go ahead and write this down. Pause the video because I'm going to erase it. Let's go ahead and identify the end behavior. Okay, let's say we're given p of x is equal to x to the 6th power minus 7x to the 5th plus x cubed minus 2. Okay, so we're given this here polynomial function, and it says for us to describe what this end behavior is. Okay, we're going to identify, in order to determine what the end behavior of this here function is, we need to identify the leading coefficient and the degree of this polynomial. Well, what is my degree? My degree is 6. That's the largest power on the monomial. Now, my leading coefficient, is it less than 0 or is it greater than 0? Well, it's 1, so it's going to be greater than 0. Okay, so A is greater than 0. Now, based on my videos before, what is the end behavior of, now, of course, you know this is an even function. Since it's even, and then the leading coefficient, of course, we know is greater than 0. What is the end behavior of this function here? Well, if it's greater than 0 and it's even, it's actually going to have the same end behavior as a parabola that is greater than 0, where the leading coefficient is greater than 0 and degree is even. Well, a parabola has an even degree. So it's going to basically have the same end behavior as a parabola with the leading coefficient greater than 0. Okay? Which will be this here. As x approaches -infinity, p of x approaches positive infinity. Okay? Let me write that infinity a little bit more clear. P of x will approach positive infinity. Well, what happens is x approaches positive infinity. What happens as x approaches positive infinity? Well, as x approaches positive infinity, this function p of x, this function p of x will actually approach a negative, I'm sorry, not a negative, but a positive value here. Okay? but a positive infinity. Now, how does this end behavior look? Well, let's graph it. Let's see, it says as x approaches negative infinity, so I'm over on this side. P of x will approach positive infinity, so I'm up like this. Then it says as x approaches positive infinity, so I'm over on this direction where x approaches positive infinity. My P of x will also approach positive infinity, so I'm up like that. And as you can see, this is the same end behavior as the quadratic parabola, as the parabola here. See this end behavior, their end behaviors are the same. They're going in the same direction. So this tells you that this end behavior here is true for any polynomial function that has leading coefficient greater than 0 and that is an even polynomial function. I'm sorry, that as an even degree polynomial function, an even degree polynomial function. And in later videos, we'll actually talk about how to take this polynomial and actually graph it. We'll talk about many different things, the local minimum, the local maximum, we'll talk about turning points and everything. And then, like I said, we'll talk about my favorite, which is actually graphing these polynomial functions when given the zeros, or when you have to find the zeros and then find the multiplicities and graphing using that. We'll talk about all the characteristics of that, how it flattens out, where it flattens out, where it bounces off. We'll talk about everything. Okay? But this is just a video basically on finishing up polynomial functions and their end behavior.